Okay, so if you've got one of our books, today's lecture starts on 9.4 and it begins on page 487. If you don't have a book, then just try to pay attention to the details on the presentation. And I'll give the assignments for both of those at the end. But title to this, if the authors had put these two sections together like they should have, would be called An Intro to Right Triangle Trigonometry. Yesterday, we learned about the special right triangles, the 30, 60, 90s, and the 45, 45, 90s. And they are special, and they are used a lot, but they aren't the only ones. Lots and lots and lots of other right triangles out there that show up in problems that you need to be able to find some things. Okay. So, I'm going to draw. A lot of this is just getting used to the way we do things. This is just a plain old generic right triangle. It's not special. It doesn't have, it's not 45, 45, 90. It's not 30, 60, 90. It's just a right triangle. But it is a right triangle because nothing that we do today is going to apply to any other kind of triangle today. Towards the end of the chapter it will, but not today. Okay, so I'm going to give these certain labels here. I'm going to call this angle A and B and this one C. And then I'm going to, the sides, if I go out into this angle, the side opposite of it, you need to be able to identify opposite and adjacent. We'll talk about what those are and hopefully be able to tell what those things do. But the opposite side of angle C is this one right here. It's the hypotenuse. So I'm going to call it little c and it stands for the length of it. Okay. So A is right here. I'm going to call this little a and it stands for the length of CB. And B is right here. Go out into that angle. You hit that side. This is side B. And if you label it this way with the right angle being C and the two acute angles being B, understanding that the opposite sides are their little corresponding letters, then you get the Pythagorean theorem. If we all agree to label the triangle that way. Now, we're not always going to use A, B, and C. We might be using P, Q, and R, or D, E, F, or we might not use letters at all. But for now, in order to reference things so that you can understand what's going on, this is going to be the way we do our triangle. Now, the next three things I'm going to put up here, they are definitions. They are not something that someone figured out. They are definitions. It's kind of like, I don't know, it's kind of like somebody who doesn't speak the English language, and you walk over and you say, you're talking to them, and they put their hand on this, and they say, what is this? And you say, that's a desk. And they say, why? And you say, because we as people who speak English have agreed to call this a desk. That's why. So when I put these on the board, it's just as nonsensical and inappropriate to say, why? Because we as mathematicians have agreed to call it this. That's why. Okay? These are definitions. Okay. The first one, the word is sine. And it's spelled this way. And the reason it's sine is it has something to do with sinus, like the space behind your bones right here. And it was a misinterpretation of the language when somebody translated it, but it's stuck. So there's no good reason to call this sine, except for everyone has agreed to call it sine. And we take the E off, and it does not become sin. Do not expose your ignorance and call that sin. It's sine. You say sine. And you'll notice on your calculators, if you have the scientific ones I ask you to get, there's a key dedicated to SIN. It's above the numbers, probably one or two rows. You see it? Okay. There is another one called cosine, and I will explain why it's called that. And that's how you would spell it. And you say cosine, but it is abbreviated COS. Again, don't say cos. It's not cos. It's cosine. Get used to it. And the other one that you see there on your calculator as a dedicated key is tangent, and it is spelled this way. And again, we cut it off to the first three letters, and we don't say tan. We say tangent. And these are definitions, folks. The definition, according to, I'm going to first write what it is with respect to this triangle and then give you a generalized idea. The sine of an angle, and by the way, I'm telling you lots of little nitpicky things here. When we do right triangle trig, which is all we're doing today, we never sine or cosine or tangent this angle. This right angle only tells us that what we're about to write over here applies, and it applies to the two acute ones. We don't ever sine, cosine, or tangent this for the next 3 or 4 days. We're not doing that. Okay? We will only sine, cosine, and tangent this acute angle and or this one. Not this one. This one only tells us we can use it, because this only applies to rights. So the sine of angle A, and it has to be followed by some angle. You can call it angle A. Sometimes there will be, sometimes instead of A, there will be a number right in the angle. Maybe it'll be 52 degrees. And what you would put is 52 after the sine. But for right now, I'm going to just call that angle. It could be any measure. But the sine of that angle is equal to the opposite side, A, over the hypotenuse, C. And so in a general way, whether we're talking about this triangle or some other triangle, sine of an angle is going to be equal to that angle's opposite side over its hypotenuse. So whether it's this triangle or any other right triangle you ever see, if you're taking the sine of an angle, your eyeballs should go to that angle, and then you should choose the opposite length and put it over the hypotenuse length, and that will be the sine of that angle. The ratio. This will all make more sense as I roll it out, but just that's how it's defined. Cosine, we'll stick with A. The cosine of A is equal to B over C. Or in other words, if we're focused on angle A, and we are, this A right up here, the cosine is defined to be the adjacent. Adjacent means attached to. The adjacent side over the hypotenuse. Now you might think, well, how do I tell which is which? It's pretty easy. This is the hypotenuse no matter what. It's always the hypotenuse. It's never named anything else. So there's only two sides which make angle A. One of them's the hypotenuse, means the other one's the adjacent. It's attached to it. Do you understand? Adjacent is the leg that's attached to the angle in question. These are legs. These are hypotenuse. That's hypotenuse. Do you see what I'm saying? So adjacent is the leg responsible for making that angle. The hypotenuse is always the hypotenuse. Okay, so I'm going to put over here adjacent, ADJ, hypotenuse. That's its ratio by definition. Tangent of A is, because again, we focus on A, and the tangent of A is opposite A over adjacent B. Now, you might look at that and go, crap, I got to know all of that? Because, you're going to have to be able to do it for B as well, because B is also acute. So if I were based on these generalized definitions right here, can anybody, according to this triangle, can anybody tell me what they believe the sine of B would be? Sorry? B over C. Because with respect to angle B, that's where your eyeballs should be going, right there to angle B. Its opposite side is B, hypotenuse is C. And sine is opposite over hypotenuse with respect to this angle. So for now, doing it with respect to angle B, we get that the sine of B is B over C. What is the cosine of B? Adjacent over hypotenuse. What's adjacent to B? A. What's the hypotenuse? C. What's the tangent of B?
B over A.
Opposite over adjacent, B over A. Okay, now there's some things I want you to notice. Sine and cosine. I need you to really pay attention here, because this is going to give you lots of insights into these things and what you can expect. Sine and cosine both have the hypotenuse as their denominator, right? Tangent doesn't. So leave tangent out of the discussion for just a minute. Just sine and cosine. The hypotenuse of any right triangle is always, without fail, the longest side, right? Y'all agree with that? Then if the hypotenuse, which is the biggest number for the sides, is in the denominator, the opposite and the adjacent are somewhat less than that. These will always be proper fractions. In other words, less than 1. Because you'll always, since the hypotenuse is the longest, you'll always have a smaller number over a larger number for these two, because the hypotenuse is always biggest. Does that make sense? So the sine and cosine of an angle, whether it's A or B, I don't care what it is, the sine and cosine values that you will get will always be less than 1, or proper fractions. Now this may or may not be. Tangent's kind of in a world all his own. Tangent, if you were playing that Sesame Street game, he would be the one that doesn't belong. Because, first of all, there's no hypotenuse in his ratio. The tangent ratio is made up entirely of legs, whether it's this one over this one or this one over this one. And the tangent of A and the tangent of B are always reciprocals. If this is A over B, you can expect the tangent of the other angle to be B over A. But we can see that B is longer than A, and so this number here is going to be greater than 1, while this one will be less than 1. So tangent is not restricted to being proper fractions. It may or may not be. You know what I'm saying? Do you? Tangent kind of hangs out on his own, and it's only made up of the legs. The hypotenuse never shows up in tangent. Hypotenuse shows up in both of those and makes their values always proper fractions. Okay, now I'm going to show you something else, and this is, you'll hear people who have studied math just about anywhere at this level will know what this means. And you have to remember how to spell it. If you ask anybody, they'll say SOHCAHTOA, and they'll immediately think of trigonometry. It's a stupid name. It's a strange, nonsensical thing, but it'll help you remember. SOHCAHTOA means this. And the reason why there are dashes in between, you have to remember how to spell it or it's not going to do you any good. It says this, that the sine, and I'm going to use color here so I can delineate it a little bit. Sine, S, is equal to opposite over hypotenuse. That helps you remember it. Cosine, that's the C, is equal to the adjacent side over the hypotenuse as a fraction, as a ratio. And tangent is equal to opposite over adjacent. That will help you remember these. If you can remember that one acronym and know how to spell it. SOHCAHTOA. Sine, that's what it means. SOH means sine is equal to opposite over hypotenuse. That dash just means we're now moving to cosine. It's not a subtract sign. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. SOHCAHTOA. That will help you remember it in case you forget which one goes with what. Question?
Why did you put B in the denominator on tangent B?
I didn't. Tangent B is B over A. Tangent A is A over B.
Why did you put A in the denominator?
Because the opposite of B is B, and the adjacent to B is A. Opposite over adjacent. A is adjacent to B, so it goes in the denominator.
Oh, okay.
You see what I'm saying? You okay with that?
Yeah.
Okay. So, how do we use these things? I mean, we've got the ratios down. Well, I'm not going to show you how to use them yet. I'm going to practice this just a little bit. If I have, one other thing I want you to get used to, and it's just going to take practice for you to understand this. This does not mean the sine times A. It means the sine of angle A. This tells us where to focus our attention and write a ratio for it. This is not sine times A. As a matter of fact, this right here by itself is worthless. It has absolutely no meaning at all. None at all. You have to have an angle on the heels of it before it takes on any meaning. It's not times. So if I had something like this, the sine of A plus the sine of B, a lot of people are right at the very beginning are really, really tempted to say, well, they both got a sine in it, so I'll factor that out. That right there has no meaning. You cannot do this. It's not a factor. It's not the sine times A. It's the sine of A. They go together with either one with the A without it is an angle, but the sine is totally irrelevant without something to follow it. So get over it that it's a factor. It's not. It doesn't behave that way. As a matter of fact, these things that you're studying today, sine, cosine, and tangent, they are called transcendental functions because they transcend the algebra that you're used to. They go beyond, they go up and above what you're used to. These are transcendental functions. Transcendental things are what you're dealing with. That takes a little getting used to, but it does not mean sine times A or cosine times A. And I know you've been taught, well, of means times, not in this case. The sine of A is a single thought, single notion. Sine by itself is worthless. You got to have something to sine or cosine or tangent, okay? All right, now, if I give you a triangle like this, it's a right triangle. And I tell you that this angle right here is, let's say, 48 degrees. And this is 6, 7, and Well, I'll just leave it like that. What if I asked you, this is a trick question. What if I asked you, what's the sine of 48? This is what I'm asking. What's the sine of 48? So your eyes go and find this angle. It's right there. And the sine would be opposite over hypotenuse. But I don't know the hypotenuse. But could I find it? Using what? Pythagorean theorem. I would. It's a right triangle. So this number right here would be, and I have to take a little sideline and get that figured out, would be 6 squared plus 7 squared equals hypotenuse squared. And so if I took that number, whatever it is, and square rooted it, that would be the hypotenuse, wouldn't it?
Yeah.
Okay, so that's 36 plus 49, which is 85. This would be 5. Now, does that simplify? Well, check it out and see. We would take, obviously 5 will go into it because it's got a 5. 5 times what gives you 85? 17. 5 and 17 are prime numbers. I can't go any further. There's no pairs. So this is the square root of 85. That's as simple as it gets because there was no pair to bring out. Do you understand the investigation there?
Yeah.
And so this would be, sine of 48 is 7 over the square root of 85. Because that's the, with respect to the 48-degree angle, it is the opposite over the hypotenuse. I had to go find the hypotenuse. So you can do that, Pythagorean theorem. This is also improper. And so it will be 7 root 85 over 85 if they want an exact answer. Can you all see that that's what it would be from rationalizing enough denominators or not? Can we show you how we get that, anybody? Anybody need help understanding how I got from here to here? Okay, you're gonna have to multiply the top and the bottom by the irrational part, which is root 85. That's how we rationalize that denominator. So if I multiply by root 85 over root 85, I'm not really multiplying by anything but 1. Anything over itself is 1. But I'm changing the way it looks, which is 7 times root 85. They don't multiply. They just hang out together there. And root 85 times root 85 is 85. So we did this part in our heads. Everybody clear? So what is the cosine of 48? What's over the 85?
7 times the square root of 85.
Is it 7?
I thought it was 6.
Cosine of 48 would be, what's adjacent to 48? Because see, cosine is adjacent. 6 over the hypotenuse. And since you already did this, that would be 6 times the square root of 85 over root 80. I'm sorry, over 85. Can you rationalize that in your head? What's the tangent of 48? 7 over 6. Done. 7 over 6 because it's opposite over adjacent for tangent. And that didn't involve the root 85. Everybody clear on that?
Yeah.
Okay, here's another trick question having to do with this exact same triangle. What do you suppose that the tangent of 42 is? No. Yes. Yes, 42. I heard it.
6 over 7.
6 over 7. People are going, what? If this is 48, this has to be 42. So the tangent of 42, you go to this angle and focus your eyes on it, and the opposite of that is 6 over the adjacent 7. What's the cosine of 42? 7 root 85 over 85? But I thought 7 root 85 over 85 was the sine of 48. And the answer it is. They both happen to do the same thing. The cosine of 42 is the same as the sine of 48. Look, 7 root 85 for the cosine of 42, sine of 48, 7 root 85 over 85. They're exactly the same thing. Now, do you know of a geometric word that is used to describe 42 degrees along with 48 degrees? What are they? Sorry? That's a good try. Not that word. Complementary. Why are they complementary? Because they add up to 90. Won't the two acute angles of a right triangle, won't they always add up to 90?
Yeah.
Because there's 180 to go around. We've already used up 90 in every right triangle we meet. So the other two have to split up the remaining 90. And so these other two will always be complementary. Do you agree?
Yeah.
Okay. So see if you understand this now, based on the fact that this, which was 42, was the same as this, the end result over here, which was 48. Those are complements, right? So see if you understand this. The sine of an angle is equal to the cosine of its complement. Does that make any sense to you? The sine of an angle is equal to the cosine of its complement. You can tell that from this because the cosine of 42 had the exact same value as the sine of 48, and 48 and 42 are complements. So the sine of this angle is equal to the cosine of that angle's complement. You okay with that? We could have decided that up here, but we don't like letters in here. I mean, letters make things. Look at this. The sine of A is A over C. The cosine of B is A over C. And A and B are complementary. They have to be. So the sine of an angle is equal to the cosine of that angle A's complement. They are the same. That's why we have the word cosine. Co does not mean like co-captain. It doesn't mean that they have the same authority on the team. That isn't what it means at all. Co is short for complementary sine. It's complementary. The sine of an angle is equal to the complementary sine of its complement. Complementary. That's why they say cosine. Okay? So that was kind of fun, little discussion.
And it could also go the other way, right? The
Yes.
cosine of A could go the sine of B.
Yes, exactly. The cosine of A is equal to the sine of B because A and B are complements.
Okay.
You okay with that? Okay. I'm going to erase all of this. I hope you have it down. And if you don't, take a minute to take a picture. I don't know if that'll mean anything, but this stuff right here may be useful to you. You can take a picture if you want. I'll get out of the way. Or you can view this video if you want. Take a picture then or whatever. That stuff over there is a mess, but all that over there is going to be important to you for the rest of this chapter. Okay? Got it? Okay. So I'm going to erase all this stuff. Try to remember SOHCAHTOA and what it means because you may need to call on it now that it's being erased. Now that you've been introduced to all three of these things, we're going to start doing some exercises or some examples out of the book. See if we can apply this. All right. So on 9.4, page 488, example 1 says, I want you to just look at it with me. Just get your eyes on it. It says, find the tangent of S and the tangent of R. I guess I better put the picture up here for those of you viewing this video if you don't have a book. But it's a really short, squatty little triangle like this. Right angle is here. And it tells us that this is 18, this is 82, and this is 80. And the question, this is S, T, and R. Notice it's not ABC anymore. What I want to do is find the tangent of S. What is the tangent of S? So focus your eyes on S. And remember what tangent is. It's the TOA part. It's opposite over hypotenuse. TOA is opposite over adjacent. So what's the tangent of S? 80 over 18. And we would reduce that because they're both even. That would be 40 over 9. Y'all clear?
Mm-hmm.
What is the tangent of T? No, what's the tangent of R? 18 over 80 over 40. They are reciprocals as we discussed. I'm not sure how, this will be fun. This is your very first example of how this can be useful to you. The next example, example 2, shows a triangle like this. It's right angle right here. There's an X here. This is 11, and this is 32. Guess what the instructions are?
Find X.
Find X. Now, first thing you've got to decide on these kinds of problems is, do you want to, in order to find X, do you want to use the ratio that involves cosine or tangent? Gotta make that decision. And the way you make that decision is this. You look at the angle that's given. They're giving us this one. This is a right angle that only says we can use trig. So forget that. This is the angle that's given. With respect to that, what is this? Opposite. What is this? Adjacent. Which trig function involves opposite and adjacent? Tangent. There's no hypotenuse involved, so sine and cosine are out. Okay, so we choose, out of the three, we choose tangent, and then we write this. We write down just exactly what we see. Remember I told you that sometimes it would be an angle? The tangent of 32. 32 goes right on the heels of that tangent, and it equals the ratio 11 over x, opposite over adjacent. Do you see it?
Yes.
Do you understand why we chose tangent? Do you understand why I wrote down what I did?
Yes.
Now what you have is a proportion. Because the tangent of 32 is just a number and your calculator knows what it is. Don't grab that calculator yet. Don't touch it. Get out of that habit. Hands off. Your calculator knows what the value of this is. I don't want to know yet. I'm trying to save you trouble in the future because I've seen students do this all the time. As soon as they see that, they grab their calculators. Don't grab your calculator until x stands alone. Then grab it to do the calculating, but not until. You do the algebra on your paper. It's going to save you lots of grief in the future. You write down the ratio. Just try to remember this is just a number, but don't find out what it is right now, but treat it like a number. If you put that number over 1, you created a ratio equals a ratio, and we cross multiply to solve. Now let me show you one way that somebody might write the cross multiply. If I take tangent 32 times x, they might write this. It equals 1 times 11. That's how we cross multiply, right? This is an improper way of writing this because it's ambiguous. Do you know what ambiguous means? Means has more than one meaning. This, when you read this, you have to wonder to yourself, do you mean for me to take the tangent of 32 and find a number and then multiply by x? Or do you mean for me to take 32 times x and then tangent the result? Can you see how it could have two meanings? To avoid that, when we cross multiply, we always stick this number, whether it's a number or a variable, I don't care what it is. When I take this times a trig function, I always put it on the front because that means x times that. Always put it on the front to avoid ambiguity. When you do that, and I've written it like this, there's only one step left. To solve for x, this is x times tangent 32, so I will divide now. And that would be 11 divided by the tangent of 32. And now you can grab your calculator, and not until, and before you type anything, make sure your calculator is in degree mode. There should be a little tiny capital D somewhere, or perhaps, depending on your calculator, a DEG somewhere in the screen. Do you all see it? Because if your screen says R or RAD, you're in the wrong mode and I need to come and fix it. You cannot figure what we're doing today in radian mode. You have to be in degree mode. Does everybody have a D or a DEG in their screen? Or perhaps nothing, because sometimes the default is always degrees and maybe they don't write anything in the screen. If there's an R or a rad, you need it fixed. Anybody need their calculator fixed? Anybody? Everybody in degree mode have some evidence of that? If that's the case, then you are ready to calculate and you will type in 11 divided by, and it will be the tangent, and quite often it will slap down its own parenthesis as soon as you type the word tangent. Put the 32 in there and close it. Make it a habit. Then hit enter and you should know how long x is. What is it?
17.6.
So apparently a lot of us are getting the same thing. 17.6. What? 6 or 7? 6. Okay. So if this is 11, this is about 17.6 in a right triangle where that angle's 32. That's about how long that is. We good? Do you understand how that works? And so that was quite an explanation. In the future, I won't spend nearly that much time doing this. Want to try another one?
Yeah.
Do it.
Okay. Take a look at page 490. There's one more example on this in this section. It says, this is a problem with context to it. It says you're measuring the height of a spruce tree. You stand 45 feet from the base of the tree, measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height of the tree to the nearest foot. So you can see the diagram of the drawing right there. how in the world would you figure out if you walked away from that tree, I mean, with the base of the tree and you counted it off, you pace is a certain length, you count it off, and you know that you got 45 feet out. So you turn around from the tree, you turn around like that, and you look at the top of the tree. How do you know that your line of sight, which was parallel to the ground, and raising it up to look at that tree, how do you know that that angle is 59? How could you figure that out? There's these really cool little things that you can make. They're real easy to make if you ever wanted to do this. And it looks like this. We made a whole bunch one year. We could do it if you really wanted to take the time. But all I've got on the bottom of this is just a pen to weight it down. And right here, sorry, I don't know if you want to zoom in on that or not, but right here is half of a protractor that we just took to the copy machine and copied on purple paper. You know, it's a clear protractor. And what you do, this is supposed to be a straw, but we put dowels on here to make them last longer. And what you do, if the tree is over there, well, like this, and I would raise that up until I look like the sight of a gun. I'm looking right on the top of this dowel, right at that thing. And I would wait for this to stop swinging, pin it down, and look at that, and it looks like about 19 degrees. So if you were 45 feet away from the tree, and you had to raise your eyes this high to look at it 45 feet away, that might be that 59-degree angle, you see? Because it goes from 0 to 90. That's how you tell. This thing is called, it's kind of a cool name, it's called a theodolite. Theodolite. And they're very easy to come up with. So that's what you would do if you wanted to measure that tree indirectly. The way to measure that tree directly, by the way, would be to take a tape measure and shinny up the tree to the very top and drop it right straight down. And that would be very difficult to do. Not only the climbing, but you might bust the top of the tree off, and it's really hard to get a tape measure to drop down through the branches right to the bottom. That would be called direct measurement. We are measuring indirectly by doing the trigonometry on it. So if we take the information that they gave us, somebody measured it with their theodolite, this would be our triangle. We assume, there's a big assumption sometimes, we assume that the tree grows perpendicular to the ground. So here's the tree, and it is perpendicular to the ground, and the guy's standing out here, and this is 45, and he's looking up at the tree with an angle of 59 degrees, and we want to know the height of the tree. You understand all the stuff I put on there?
Yes.
What are we going to use to find it? Tangent, so sine, cosine, or tangent? Tangent, because there's no hypotenuse involved. That's just a line through the air that's not really in this picture. Just what you're looking at. So we would write the tangent of the angle 59 is equal to opposite x over 45 adjacent. Opposite over adjacent. Do you see it? Create or imagine that this thing is a proportion, and we would have 45 tangent of 59 equals x times 1. And happily on this one, there's no division that's required. It's done right here because the number ended up in the denominator. We were able to just take times the tangent of 59. So once x stands alone and you've done the algebra, then you can grab your calculator and do this process. In this case, it's a multiply. So you take 45 times the tangent of 59 and you get
74.89.
So 74.9, nearly 75 feet. I'm just going to say 75 feet. If they ask you to round to the nearest tenth, then you follow the instructions. But about a 75-foot tree, if these measurements are fairly accurate. Okay? Y'all understand how that happened?
Yep.
Okay, moving on. Go to section 95. Page 484, no, sorry, 494 if you're following. And they give you the other two, which I've already given you. So let's jump to some examples. I have the example 3 is where I want to go next. No, I want to do example 2 because I want to drive home this idea that we talked about a few minutes ago. It says write example 2. I've changed my mind. I'm going to example 2. It says write the sine of 56 in terms of cosine. Means equals some cosine of what? The sine of 56 equals the cosine of what?
34.
34. Good. Because if the sine of 56, you have to find the complement of this, which is 34, because the cosine of this thing's complement is exactly the same as the sine of the original. That's what they mean when they say, write this expression in terms of cosine. This is in terms of sine. To write exactly the same value in terms of cosine, you need to find the complement of this angle. That's what they're asking you to do. Is that okay?
Yeah.
Because that's the discussion we had a minute ago. Okay, example 3. Example 3, I'm going to erase this tree problem so I can stay on camera here. Example 3 has a diagram like this. The instructions are find x and y. You can't do them at the same time. So let's say we wanted to find x first. So you ignore y entirely and you ask yourself, which trig function relates this angle to this side and this side? Because I'm ignoring the y.
Sine.
Sine, not sin. Sine. It's okay. The reason we chose sine is because with respect to this angle, and I'll always say that, with respect to this angle, this one that we want to know is opposite. The one that we do know is hypotenuse. And OH, opposite over hypotenuse, belongs to sine. So we would say sine of the angle equals x over 14, because that's opposite over hypotenuse. Cross multiply, 14 sine 26 equals x, and we have x as soon as we calculate it. Did I go too fast for anybody? Anyone?
No.
Okay, with respect to this exact same angle right here, how do we find y? What function shall we use?
Cosine.
Why cosine?
Because it's complementary to the sine of.
It's complementary. No, that's a nice answer, but that's not the reason why. Why do we choose cosine to find y? Because y is adjacent, and 14, which is the other one we know, is hypotenuse. That's the ka part of it, CAH. Adjacent, hypotenuse, we choose cosine to find y. So we say the cosine of the angle, always of the angle. Some people, that's another thing people screw up. They want to say the cosine of x or the cosine. You never sign cosine or tangent aside, ever. You always sign cosine and tangent and angle. Even if the angle is unknown, you sign cosine and tangent, the angle. It's always an angle. Equals adjacent over hypotenuse. Again, we cross multiply. And then calculate. And don't grab your calculator till y or x stands alone. You get the algebra done first. So 14 cosine of 26 will be the length of y. I imagine you can do that. Okay, moving right along. Take a look. Let's do example 6. Example 6 on page 497. It's another one with context. It says, you're skiing a mountain with an altitude of 1,200 feet. That means from the base. They don't mean from above the ocean. From down where the lodge is and everybody's parking and everything, you've gone up 1,200 feet to ski down. So that's the height from the lodge distance, okay? The angle of depression means you have to lower your eyes. So I'm standing above, I'm right on the brink of going down this hill. This would be my line of sight. And to look at the lodge, I have to lower my line of sight like this. This angle is the angle of depression, okay? So they're saying the angle of depression is 21 degrees. Find the distance x that you get to ski down the mountain to the nearest foot. Now this can get you in trouble if you do not pay attention right now, because angles of elevation and depression are weird. We did the one with the tree and we said the angle of elevation because we had to raise our eyes up. Here is the top of the hill, right here. Here's the lodge down here. We want to find this length right here, and we were told that this distance, this vertical distance, is 1,200 feet. Do you agree?
Yes.
Now here's where we don't have a picture to go with this. We'll pretend the lodge is here instead. Okay. I want to know how much I get to ski in feet, knowing that this is 1,200 feet up. People are so desperate, and it is a desperate thing, to put an angle in a triangle that they say, okay, I'm the skier up here, and I have to lower my eyes this far, 21 degrees. They always put the 21 right there. That is not what an angle of depression is. An angle of depression is from your sight parallel to the ground, how much do you have to lower it? That's 21 degrees. And if you draw this triangle, which is the most, what's the word? Obvious, I guess, triangle for this situation, the angle of depression is not in the triangle. Get over it, deal with it, and understand that this line is parallel to this one, which means the angle in this triangle is 21 degrees is this one. Because alternate interiors are equal. This one's outside the triangle because that's how much you have to lower your eyes. So the 21 does not go here. The 21 goes here, but if you want to use it in the triangle, it actually goes down here since alternate interiors are equal. Do you see it?
Yes.
Be careful with angles of depression. Okay, so if we know this is 21, this is 1200, I want to find x, what function shall I use?
Sin, sine.
Sine. Why sine? What's opposite? The 1200. What's hypotenuse? The thing I want to know. Yeah, or x. So the sine of the angle, which we know is 21 when we put it in the right place. The sine of 21 is equal to the opposite over the hypotenuse, which is the length of our hill. When we cross multiply, there's going to be one extra step on this one that we haven't seen for a little while. But when you cross multiply here, you get x. Sine 21 equals 1200. And then you have to divide by the sine of 21. X equals 1200 over the sine of 21. And then, and only then, do you grab that calculator to make a calculation. So what is 1200 divided by the sine of 21? To the nearest foot. 3,349 feet. Okay. Is that a mile? More than a mile?
No.
No. A mile is what?
5,280.
5280. So if you wanted to know how long this was in miles, it would be less than 1 mile. But how could you figure it out? Like, is it 0.6 miles? Is it 0.8 miles? How do you figure that out? Yeah. No, the other way around. You take the distance, the 3349, and you divide it by 5280. What part of a mile is this? I just want you to investigate it. This is the answer to the question. But about how much, what?
0.6.
Okay, so 0.6 miles. Is that a pretty long ski hill, or for those of you who ski? It's not all that long. If you can get a nice hill that's well groomed and a nice sunny day that's 4 miles long, that's a fun trek. I love to ski, but I like it. I'm the kind that wants to keep my skis on the ground. I want to ski where it's groomed. I don't like bumps. I don't like powder. I just want to go fast. Just let me out. Anyway, so that one's around 3,400 feet. Okay? You turn the page, you're at the exercise for section 9.5. So I think you have the information you need to do these problems. You have to choose the correct function, do the cross multiplying in algebra, and then grab your calculator and not until. So on section 9.4, because you got an assignment on both sections, section 9.4's assignment is, you ready to write? 1 through 23 odd. And I know this is weird, but as you're going 1 through 23 odd, add the number 14. So it's 1 through 23 odd and then 14 stuck in there. Okay, and you can do 14 last if that's what you run into. That's fine. I don't care when you do it, but 14's got to get done. And on 9.5, it's just 1 to 31 odd. 1 to 31 odd, that's it. Okay? You haven't got a lot of time left today, a little bit. You can probably get a good start on this and ask some questions, but you can have tomorrow to work on it too. Okay?
Oh, actually?
Okay, so that's that. I hope you learned something.